Hello, 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 hello. Okay, so today we are going to learn some data structures and algorithm like low level TS and yep. Oh, why did I pause it? All right, so okay, so start with the asymptotic, th- asymptotic, asymptotic analysis. All right, so basically these are the analysis which we call it the notation, like the omega notation, the big O notation. These notations are come on this asymptotic notation. All right, so the above discussion for all the three notations, worst case, best case, and average case, we can easily understand data. In every case of the given function f, and we are trying to find other function gn, which approximates fn at higher value of n. This means that Gn is also a curve of an approximate Fn at higher values of n. In mathematics, we call such curves as asymptotic curves. In other terms, Gn is the asymptotic curve for Fn. And for this reason, we call algorithm analysis as asymptotic analysis. Alright, so in this graph right here, we can see that this is the Fn, like this is the Fn graph, and in here we have two c1 g and function, and then there is another function. Okay, so this is the input size. So on depending on the input size, the function gets like makes it curved. All right, so these are asymptotic analysis. All right, so guideline for asymptotic analysis, there are some general rules to help us determining the running time of an algorithm before we view up them. First is loop. The runtime of loop is the runtime of the statements inside the loop, including test, multiplied by the number of iterations. Okay, so we have to multiply the number of iterations. Right? Alright, yep. So that's why the constant C this here into n time, that is Cn, that is big O of n. Alright. So, all right. Yep. But in nested loop, analyze from inside out, turning a total loading time of the product size in the loop. So there's an n inside an n, and there's inside an n. Then Cn into n is Cn square, and then we got the n square because we do not take the constant seriously. Okay, alright. Now consecutive statement at the time of the complexity of each statement. Okay, consecutive statement. All right, c0 like constant 1, constant 2. All right, we ignore them. If else statement, worst case running time, the test plus is 1. All right, another part of it is else part. Okay. Oh shit, it's so fan. Okay, so we are checking that this is in false and part constant else the best. Okay, so we have for loop here. That is one. Now logarithmic complexity. So if it takes a constant time to cut problem size by a fraction, usually by 1 by 2, for example, this program, the for loop and its time, the I is multiplied by 2. Alright, so if we observe carefully, the value of I is doubling every time. Initially I1, next step 2, and subsequent I's 4 and 8 and so on. Alright, let's assume that the loop is executing k times. That means kth step is 4 to the power I is equals n. And we come out of the loop, so we take the logarithmic of both sides. Log I is equals to log 2, and log 2 is log n. I log 2 is log n. Then I is equals to log. Okay. Log n, correct. Correct log. Let me check this one. This rate correct. N square and log. What is it saying here? That if you observe carefully, the value of our step initially this, next step 4 and subsequent. Okay, now let's us assume that the loop executing some k times. K times. Alright. K times. That means kth step is 2 to the power I. 2 to the power I is equals to n. Is it? Is it? And we come out of the loop. So if we take logarithms of both sides, yep, how it 2 to the power I is equals to n. Why is that? Why is that? Let's do grok. Grok, 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 grok. Wait a second, let me check it out with this. Uh, y is 2 to the power, 2 to the, what's the caret? 2 to the power is equals to n. Is it? Is it or not? 2 to the power I is n. Why not? How? How? How 2 to the power is n? The equation 2 to the power n, 2 raised to the power n arises from the analyzing the loop where the value of I doubles, in each iteration. This starting from I is equals to 1, the loop continues until I reach. Starting from I is equals to 1, the loop continues I reach or exceeds, and this means that after k resonance become 2 to the power k. What? And a loop exits when this. We take logarithms of this. Can you give example? It seems like you might type on your request to minutes. Yep. For 8. Oh shit. Shit. Initial is 1, then 2, then 4, then 8. Exit loops. So where's that? Runs 3 times. Okay. Runs 3 times. Confirming the logarithm's relation with 2i. Yep, I got you. I got you, my boy. So basically what's happening in here is that I put the value of n to be some number, but we are seeing here that this I is jumping up by 2, like 2, then 2, then 2, then 2, means whatever the number of i's, that will double up the number. Correct. Let's say from I is 1, then it will be 2. It's 2, then 4, that means it's multiplied by 2. So basically we're not iterating over each value. Correct, each value. That's why it's not n, and instead it is log n. Alright, it is log n. That's why we are taking this, that 2 to the power n, 2 to the power I. Alright, 2 to the power I. So 2 to the power I. Okay, then log. Okay, so I need to know more about this log. Tell me about log, cause I am illiterate. I'm literally illiterate because I don't know the spelling of illiterate. Alright, so I'm illiterate in math. No? Wait. No worries. Left breakdown simply logarithmic. A logarithmic or log. Just to figure out how many. Okay, so think. Okay, for example, the base of 2 with base 2 returns log 2. Alright. Basically with the number. Wait. If you know log 2 is 8, log 2 is 8. You're asking how many times do I multiply 2? How many times do I multiply by 2 by itself to get 8? That means 2 to the 4 to the 8 multiplied 2 3 times is this. So log 2 8 isn't, no, not that one. It's like counting the levels and doubling game. That's to make sense. What is the inverse of log? 2 to the power 3 is 8. Oh, dang, 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 bro, dang. Okay, that means what does it mean? Is that, let's say 5. Alright, make it black. 5. 5 to the power 3 is equals to what? Is equals to 25, 125. 125. Alright. The cube of 5 is 125. No, that's not it. That's not it. So it always, so the inverse always be in base 2 and then it has some power. Not exactly. Oh my god. Oh. Okay, so that's log 5. Right? Log base 5. Log base 5. So that means that log base 5 log base 5 125, correct? Log base 5 125. That's it. That's it. That is the answer is power. The answer is power. Alright. Always if you log this and base 2, the answer is 4. That means, okay, so basically I want to understand that we have a power 3. Alright, 3. And power is upon some base. Okay, here we have the base 5. So the power is 3. So basically it gives 125. But what is the what is the way to find the value of the power, right? So we'll write this equation like this, that log base 5 is 125. That means what we keep on the power of this base to get 125. That's it. 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 So how do we write this? Like um um how do we write this? Like what is the, okay, okay, so what is the value on the base as a power to get the value inside the log parenthesis is the log of that. Is it? Is it? It seems like you are trying to understand the relationship between the logarithm and the inverse. Let me clarify step. You have log b this means this. So the base. So yes, if you take the base raised to the power of the log number you get the number back. Does it help? So if you take the base and raise it to the power, that is the log of the number. That is the log of a number. You get the number back. You get the number back. Does not. Okay, so I have to read it out. It seems like you are trying to understand the relationship between the logarithm and its inverse. Let me clarify step by step. Log base p of x is equals to y. That means the power of p is equals to x. Yep, the power of p is equals to x. Here b is the base, here b is the base, and x is the number inside log parenthesis, and y is the logarithm result, how many times multiply, and y is the logarithm result, how many times you multiply by p by itself to get x. Write in simple phrase to understand logarithm. I wanna post him. How many times? I like a countdown. How many figures? How many times? Logarithms are like a countdown to a figure. Log are the count like a countdown of figure out how many times you multiply, how many times you multiply the number by itself. Get another number. Yep, I got it. Got it. That's log. Okay, so basically that means how many times this is multiplied by itself to get this number. Okay, we are done. Fine. Sorry. Excuse me, sir. Alright, now if we observe carefully, the value of I is doubling every time. Now this log n. Now similarly for the below case also, the worst case rate growth to O big of log n. That means the same discussion holds good for descending sequence also. Yep. We are doing the same thing, but how do we find this thing? Right, so we are finding this like this, that it goes up to 2 by 2. All right, now we are keeping that because we are going because we are multiplying everything with 2. not static, I think. In here it's also log of n. Another example of binary search, finding a word in dictionary of n pages in the center of the point of the dictionary is word toward left or right center. Repeat the pulse with the left part. Okay, I know this. I know this binary search. Now it's true, false, true, then go, then true, false, then true, then true, false, then true, then true, false. That's it. So alright, now properties of notation. Okay, now the transitivity fn is big O of gn, and gn is equals to big O of this. Oh my god, this is quite dangerous. Okay, symmetry. Okay, transitivity when fn function of this n is big O of gn and gn is big O of hn, then fn is equals to big O of h for valid O and omega, big O and omega also. Now reflexivity fn, I don't understand really. Symmetry. Properties. Let's leave it out. Now commonly used logarithm and summations. Okay, now logarithm log x, log base x. Now I'm fucked. Now I am fucked. Okay, log x to the power y, that means y log x. That's it. Log n is log n is log n is log xy is log x plus log y. Log raised to the power kn is log n to the power k, and log into log n is log of log n. Log x, wait, I know it. Now a raised to the power log x b, that means log b to the power x. That's it here. So what we get is equals to log x log, oh damn, into log. Okay, that's very arithmetic series is when we start with 1 and go up to n. I know this is the sum of the natural number n into n plus 1 by 2. I know that's geometric series. That means first 1 and then we'll go the power of n, like exponentially. Like first 1, then x, then x to the power this, and x to the power 2 plus 1, then x to the power 2. So the formula is x to the power raised to the power n plus 1 minus 1 by x minus 1, where x is not equals to 1. Harmonic series. Harmonic series is sum of n term from 1. Okay, sum of 1 by k is equals to 1, then 1 by 2, then 1 by 3, then 1 by 4, 1 by n. So we got log n here. Alright. Summation of log k from 1 to n, that is n log n. And summation of k to the power p from 1 to n is what? 1 by p plus 1 and raised to the power p plus 1. Okay, so that's a lot of formula in here. That's a lot of formula in here. Okay, let's read it one by one. Let's get this understand here. Log formulas. This is some basic logarithm formulas explained simply. Basic definition: log base px, that means y, that means b to the power y is equals to x. All right, we know that, we know that, we know that. Now change the base. Log b x is log kx by log bx, where k is the base of an 10 or e. That means log 2, log base 2 is 8. That means log base 10 8 by log base 10 2. X then b. All right, product rule, I know this. The quotient rule, log bx by y is, yep, I know this, I know this. Power rule, I know this, and log b and log base bx. Now inverse property, that b log base p of x, and we get is equals to x, and we get log base p on b raised to the power y versus y coming form. Okay, now let's solve this formula. Solve this formula using quotient. Yep, I wanna know how this works. Okay, solve log n. It seems like you want to solve. Okay. Now, change with this log 2, then log 10. What's the value? Okay, now the log 10 8 is this, and log 10 2 is 0.3. Then which means 3, and which matches this. Okay, now product rule. What are we doing here? Product rule is this. What's left inside? Log pxy log pxy, and then okay, so let's check this. Let's solve it. Is it working? Oh no. All right, now what are the 8 and 2, correct? X is 8 and y is 2. All right, so if we do log b, what is the space? Let's do base is 2. Alright, let's take base as 2. Base is 2 also. Okay, base is 2. That means log base 2 of 8 into 2. Alright, is it equals to log 2 of 8 plus log 2 of 2? Yep. So if we do log 2 of 8 plus 2, that means log of 16. Log 2 of 16. Correct. Log 2 of 16. Yep. And we know, what we know is that was the power of 2 to keep this 16. That means 2 to the power 4. Okay, 2 to the power 4. That means 4. Alright. And then log 3. Correct. 3. And then what do you keep the, okay, 1. That means if we keep the power on the base 2 as a 1, then we got the 2. Alright. That means 1. Yep. It's working. Let's take a hard one. Okay. Let's take this inverse property rule. Power rule and inverse property rule. Okay, because this is same as this. So power and inverse. Okay, basically what we're doing is, oh no, log 2, log base 2 of 8 square 8 raised to the power